Okay, let's start with designing notification system. So let's say you got a question to design a notification system in your system design interview round. What we'll try to do is we'll take up some requirements. We will understand few components which you can address, and then depending upon the interview which direction it is going, you might be asked some follow-up questions. So what we will do is we'll take up couple of components and try to go into a little bit of depth of each one of it as much as possible, so that you can talk about every component that gets involved in a notification system for, let's say, 10 to 15 minutes or so. Okay, let's get started. So first thing is to gather some requirements. So what we can think of is you can ask about notification types. Okay, so there can be couple of notifications that you might see in your day-to-day life. These are the mobile push notifications. We It can be both iOS and Android. Then you have seen notifications over SMS and over email as well. Now we can ask about, are these notifications real time or near real time? It can be, interviewer most likely will say it needs to be as much real time as possible, so it can be near real time system. Then notifications can be triggered by client side actions or some computations done at server side. So because of that, right? So the notifications can be, let's say, client or the user here did something, and because of that some computations happened at the server side and it got triggered due to that. Or let's say purely due to the server side computations, for example, let's say based on the user personalization, um, they are trying to sell their newly launched product, so they are trying to push their ads for that, and then they can send you push notifications both on your iOS and your Android devices, or even over email you might have seen couple of ads being sent to you as well, right? Users can opt in, opt out of getting the notifications. So sometimes we have seen that some products become useless for us over after a certain period of time, or let's say a certain app is sending too much notifications, right? So there may be couple of users, and there definitely are couple of users which want to opt out of those notifications. So we need to give an option to a user to do that. Then we need to decide on the scale. So let's say the interviewer mentions that it needs to be scaled up to, let's say, sending out somewhat around 1 plus million notifications a day, which is quite a lot. Now let's discuss on types of notifications. So as I mentioned above, there are push notifications on both your iOS and Android devices. So what we'll do is we will discuss in some time that all this process of sending out notifications, we will be using a third party for that, right? A third party service, and it's always good to do that. So there is no harm in doing that. You It's very unlikely, like, a company should focus on their core business, core product, and the business logic rather than building everything in house. So it's always good to rely upon already made good third party products and services, third party products and services, rather than, and not to build everything from scratch in house, right? So we will be using, for iOS to send out notifications, we will be using APN, which is Apple Push Notification. For Android, we will be using FCM, which is Firebase Cloud Messaging. Then for SMS notifications, we can use Twilio. Similarly, we can use for email notifications, SendGrid, MailChimp, etc. We will call APIs of these third-party providers to send out respective notifications. Makes sense, right? We will integrate with these third-party providers. They will be exposing some of their APIs, which we will be calling, and then these third-party providers will do the rest of the work, to further carry those notifications to the end user or the end devices. We need so we need important user details beyond the message template payload. So as I mentioned, we will be calling the APIs of these third-party providers. Now you might be thinking that, okay, now you might be thinking that we need to call these APIs of these third-party providers. So we will be saying, okay, send out a notification saying anything, let's say telling about a new product that has been launched with a certain template, okay, and a couple of messages. But how does the third party provider knows that these notifications I need to send to these devices or this email or this SMS, right? So we need some important user details to also send that to the third party provider so they know which further devices or users to target to, okay? So for example, say for iOS and Android, to uniquely identify the devices where the push notifications can be sent, we need something as device token. For email, it makes sense that we need primary email of the user. And for SMS, it also makes sense that we need primary phone contact of that user. It's the best thing to do so you can focus on your core product and business logic instead of building your in-house notification providers. Makes sense. As we just discussed above, this completely makes sense to use and integrate the third party providers which are already doing the heavy lifting for us rather than building everything in house. In that way, by delegating this work to the third party provider, we can focus on our core product and business logic. These third party notifications will do the heavy lifting for us of actually sending out these notifications. Again, as we discussed above, once provided, so once provided with all the required stuff, these third party providers will carry out all the heavy lifting work. Okay, let's see whatever we have gathered till now. Let's see on a very high level what sort of design we can start with. So very high level to store important user details which will eventually be needed by these third party notification providers. So let's start from that. Okay, all these user details, what is required and how it would flow from a client to the notification providers. The flow would look like at the user sign up or the registration process. During that, what we can do is user comes via app or website, request goes via load balancer, then this is a user sign up or register request. It goes via the API servers and we will hit the DB to persist, right? To persist the user details, right? All the user details, all the important ones, right? This DB can be an SQL or no SQL, depending upon what you want to store, how you want to scale, what are the trade-offs, what are your use cases, so and so. So DB to persist all the required information. Okay, let's see what sort of DB schema we need to have. So from a very high level, let's see what all fields are required and why they are required to fulfill our requirements. So we can have a user table and then we can have a device table. So for user table, I can have a user ID. This seems an important thing. Okay. Then this user ID also needs to have an email. Email, we need to send out email notifications as well. So a primary email. Then we need country. Okay. Just to see out all the country code and that sort of stuff. Okay. Or if want to, like we from the business side of things, our business logic, we want to compute the language in which to send it, right? What's the famous language used in that country or the country code, etc. To extract out that sort of stuff. Then we need user's name, that is fine. Then we need user's primary phone contact details to send out the SMS notifications. And as we mentioned in the requirements, we an interviewer discussed that we need that the user can opt in and opt out of getting notifications, right? So we can have a field for that as well, which can be a boolean. Okay, that can be an opt-in or opt-out. We can keep by default as opt-in as true, and the users, if they don't want the notifications or if they are getting too much of notifications, then they can opt out for that as well via a separate API call and a separate flow. Okay, so this can be a boolean to overall mark if user wants notifications or not, can be further shifted down to each device level. So here we have kept it at the user level. Okay, we have kept it at the user level. So if they opt out over here with our current DB schema, they will have to opt out of all the notifications. But as I mentioned, it can be shifted down to each device level as well, like just for the phone, just for the email notifications, just for their devices, right? That sort of stuff. Each user now can have multiple devices. So a user will have a one-to-many relationship with the device table. Let's see what we need important stuff in our device table. We need device ID, so that's quite important. Then we need device token, and this device token will be useful with sending out iOS or Android notifications via APN or FCM, as we just discussed above. So that takes up the device token with the other required message payload, template, and that sort of stuff to send out push notifications to that specific device. Then there is definitely a user ID, and then we can have a device type as well. Basically, the device ID, device token per device type, right? So this makes sense. Now let's see on a very high level how things will work with just what we have discussed till now. So we can see that there can be a lot of services. Okay. So these all can be microservices. Let's say service one can be, let's say, I want to order food, right? Service two can be, I want to make payment. So payment microservice. This is order food microservice. Service three can be, let's say, I want to um, maybe do some sort of personalization, right? That sort of stuff. Service in can be something else. This can be, let's say, ad service, right? So ads microservice, right? So a couple of services going on. All these services, let's say, interact with a notification system black box. Okay. So we have kept this as a black box because we are designing it with what we know as of now on a very high level. So let's treat it as a black box, as an overall system, which does, let's say, 5, 10, 20, 30 things inside it, which we don't yet know about. Okay. At the end, we discussed above this notification system black box will call the third party notification providers APIs. So all these respective APIs, because all these APIs, they can have um, different contracts. So we have to construct things differently. For APN, which is for iOS push notifications, for FCM, which is for Android push notifications, we will be calling out SendGrid to send email to specific users. Then we will be using Twilio to send SMS to users' phone. Okay. This seems fine with what we know as of now. Now, all these services, say payment service, order service, ad service, etc., will call our notification system black box, which we will expand and discuss on each of its components, which can go inside this box down below, which will further invoke APIs of these third-party notification providers. And then from there onwards, these third-party notification providers takes care of the job, basically taking out that message, the email, the SMS, contact number, template, message payload, device token, all that sort of stuff that is required, and then take it further and deliver it to users' specific devices, email, SMS, and that sort of stuff. Okay. Now let's try to think on a couple of things. So what we have discussed just now, we can think about what all components this notification system consists of. Okay, we can think of one for this. Makes sense because we just treated it as a big box. Now, how we segregate which notification third party provider APIs to invoke and with what payload. Now, this also makes a lot of sense that how my notification system box will determine which notification third party provider API to invoke so that it can take it further. As we just discussed above, APN, FCM, Twilio, SendGrid, all these third party providers can have different API contracts. So, how to deal with that? That we will also need. how to get the important user specific info, say email, contact, device token for each device type from the DB as we stored earlier during our register sign up flow. Now, this also makes a lot of sense, right? We discussed here at the user sign up flow that during the registration or the sign up process, we will extract out couple of important information from the user: email, SMS, phone number for SMS, email for sending out email notifications, and from which device that user is registering or signing up, so device token for that. Okay, so couple of questions. Let's try to think and like brainstorm on each of these questions and try to go a little bit in depth what needs to, how to tackle these sort of questions. Now, seems like these heavy computations need to be done at server side by our notification system black box. Makes sense that this notification system will have to do lot of heavy computations, getting user details from the database or wherever we have persisted, then forming that specific message template, message payload, forming that sort of message and sending it, comparing it with whichever API to call, APN, FCM, Twilio, etc. And then to calling that API, getting back the response and that sort of stuff, right? So these seems like some heavy computations going on. Let's consider our notification service, which can be scaled horizontally based on load. This connects to our DB to get the user and device specifics. So makes sense. So we can horizontally scale our notification service by putting up more server nodes. Okay. Now this notification service, we will think about that this will also connect to our database where all our user specific details are present, which we took up at the sign up registration flow process. We can also think of integrating caching strategy as those user and device specifics like their primary email, phone, device type with their device tokens don't change that often. That also makes sense, right? So we can implement a caching strategy in front of our database so that once they are cached with a TTL, so the notification service doesn't have to fetch it always from the database for each of the notification. So the notification system, notification service can fetch it going forward from cache, till it expires based on the TTL we mentioned, right? After its expiry, it will be a cache miss post expiry. And again, similar thing will happen. It will fetch from DB plus store in the cache again, right? Makes sense. Then to scale things further, as we discussed above, that we need to scale up to 1+ million notifications per day. And as we just discussed that these notifications involve heavy computations at the server side. So we don't want our server to get too much overloaded, like a lot of memory CPU spikes in it, so that we are like scaling and scaling further, right? So what we can do is we can segregate firstly each type of notification, and then in front of that we can add up message queues like RabbitMQ. So what I can think of is that we have couple of third-party notification providers integrated. So what I will do is I will take out, like extract out all that sort of segregation load from my notification services and take it out and have my message queues. We can use RabbitMQ and we will have these message queues per third party notification provider. Okay, per third party notification provider. So this segregates a lot of stuff for us. And then these segregated workers or the consumers can then have their specific logic which with whichever third party notification provider they are integrating with and invoking the APIs. Let's see in some time how we can build things on top of this thought process. So having a message queue per notification type, and based on the topic, our notification service can send it to that respective message queue, right? So we can take up couple of approaches. Let's say we can take up a topic approach. So we will have these topics for these message queues, and a notification service will send that, forward that notification to that specific message queue, like publish it to that specific message queue from where the consumer will take things further, having each consumer for that specific message queue, and then invoke the third party notification provider. As I just mentioned, then we have consumers, workers per queue that consume the message payload and send it out to their respective third party notification providers. Okay. So let's see it in a diagram, what we discussed just now, all the caching strategy, segregating stuff out of notification service, um, to have separate message queues each, like per specific notification, third party notification service provider, then having our consumers or workers consuming the message from those message queue, and then interacting it with their respective third party notification provider with what we have, with what specific with whichever specific third party notification provider they are working for, right? So let's say again similar thing, we have couple of services, let's say ordering service, payment service, ad service, right? Calling out our notification service, right? Then this notification service now needs some important stuff. So it would try to first invoke cache for that specific user details to whom, or the device tokens to which we want to send out the notifications. If it's a cache hit, then it's good. If it's a cache miss, then it would hit the DB, and then the results would be first stored in the cache and then sent back to the notification service. Now, these notification server would then call these message queues. They will publish the notifications on these message queues. Now, as we discussed above, it's better to segregate stuff. So we can think of as having a message queue per notification type. So we can have an iOS message queue, an Android message queue, SMS message queue, email message queue, right? So that we can tweak things here and there. And then if the load, let's say, increases on iOS and Android message queue, then we can accordingly tweak the configs of those message queues and the consumers or workers, and not touching out much on the SMS and email message queue or vice versa or something like that, right? So we have segregated things to scale things separately, right? So let's discuss for the iOS message queue, and similar thing would apply for others as well. So once messages are notifications are pushed to the message queue, we will have these consumers or workers which will consume messages from these message queue, and then tweak couple of other things what they want, and then basically having some adapter or something in place which will deal with the third party, here in case for iOS, APN, which is Apple Push Notification, third party notification provider, and to align with the API contract of that, right? And then hitting that API. Similarly, this will be done for Android message queue, SMS message queue, email message queue, so and so. Okay. And then these third party providers, as we discussed above, takes care of the heavy lifting of making sure that the notifications get delivered to the user specific email, user specific phone number, or their device tokens, like per devices, right? Now let's discuss couple of things, couple of these components a little bit more in detail. Although this seems like a decent enough design from what we started earlier. So we started with this, and now we have expanded our notification system black box a little bit, right? Notification servers will extract user specifics, say contact, email, device token for each device. This needs to be done, right, over here. Now, this can be done from cache, as we just discussed a few minutes back. If a cache miss happens, make the lookup in the DB and also store it in cache along the way for further notifications for the same user and its devices. And this is what caching strategy is, so it makes sense. This will then do computations and create message payload, which gets pushed to the specific message queue. So now we need to publish events to the message queue. So we need to construct that event involving user details like phone number, email, device token, maybe notification ID, user ID, and the message payload that we want to be pushed as a notification to the end user. So let's see what things from a very high level it can have. So we can have a target object with say user ID, contact, email, device token, device type, etc. It can even have event ID to segregate between the events, then have notification ID, then can also have their priority, then created at and couple of other fields as well. Makes sense, right? And it needs to also have the message payload constructed out. So this can be part of that event, which we will be publishing to the specific message queue where we want to get the notifications delivered out. They are then sent to specific message queues, which are consumed by our workers and then pushed further to the third party notification providers by invoking their APIs and sending out all the required information as part of its API contract. Makes sense, right? We just discussed above. So, why this segregation? This segregation is good strategy as outage, as we just discussed above, that it's good that we can scale things independently. And then if there is an outage to a specific area, say there is outage to FCM or its message queue, like there is outage to FCM message queue, let's see it from the diagram. There is an outage, let's say at FCM side, FCM workers, FCM message queue or something, anything at the Android level, right? Still, iOS message queue, SMS message queue, email message queue, and their end things would work, right? So user continues to get notified still via email, SMS, iOS, and this totally makes sense. So that is why segregation seems good. As these workers might take some time as they consume a message from their respective message queue, again do some computations as we just discussed that they might be having adapters, extract out the necessary details from the event, extract out stuff from events, payload, and then map to the third party notification provider, third party APIs, triggering that, and then making sure it gets delivered to that, right? That all that sort of stuff. So they do some computations and trigger out its specific third party notification providers. The third party notification provider now might succeed or fail. In case of succeed, our workers sends back an sort of an ACK to its respective message queue so it can delete that message from its buffer. And this makes sense. Let's say we were using RabbitMQ. So the iOS message queue, okay, it the message got published there, then its specific worker consumed the message from it, sent it out to the APN, which is Apple Push Notification Provider, waited for a response, and then once it received a successful response from the third party notification providers, it sends back sort of an ACK to the message queue so that they can delete that message from their memory. Now, what happens in case of failure? Now, in case of failure, let's say the third party notification service provider was down for a couple of seconds or minutes, or let's say the network got broken down, there was a network partition in between while triggering that third party call, API call. So the workers will say no act, and MQ will trigger a retry mechanism for that. So we can have a configuration set up with our MQ, with our message queue, so that once worker responds with a no act sort of thing, so our MQ can trigger the retry mechanism, let's say 3 retries or something like that. So the same thing happens again, and till then it keeps a hold of that message in its memory. So generally with retry mechanism and all this sort of stuff, it is good to have all of this with a TTL so we can fail fast. So there could be a very huge latency coming from the third party notification service provider end. So we shouldn't rely on that. So it's always good. And that too, we have a retry mechanism in place. So that can increase, like bump up our system's latency a lot. So it's good to have all this with a TTL so we can fail fast things. Let's say we can have a 1.5, 2 minute sort of timeout. Let's say example, a 2 minute timeout. So if this timeout is triggered, so we will until then we didn't get the response back. Until then we don't have response from the third party notification service provider, notification provider. We mark it as fail, and then retry mechanism kicks in. As we can all of as we can see, all of this seems computationally expensive. During that time, our specific message queues can get clogged with lots of new messages. Makes sense, right? Now, if let's say what we discussed just now, that couple of messages get published to the message queue per notification type message queue, and then the worker is extracting out a message from the message queue and then delivering it to the by invoking the third party notification provider's API. If it succeeds, well and good. If it deletes, it sends sort of an ACK to the message queue, which deletes it from its memory. But if it fails, then it retries a couple of times. Let's say we have said 2 or 3 times, and this keeps happening. So the incoming message events won't stop. Our notification service is still pushing couple of messages during this time. All these computations are happening to our notification specific message queues, right? So if we follow this, a specific message queue, let's say the iOS and Android message queue had good amount of load coming in, so this can get clogged with a lot of new messages. And this makes sense, right? So what we can do is we can discuss couple of things during the interview. So what we can say is we can configure prefetch. So it has the message queue has a prefetch config. So let's say we can set it as 5, which is generally used as well, which is generally how many messages our workers will consume and handle in parallel. So it's not like our worker will extract one message, then call the third party API, and then behave accordingly to kick in the retry mechanism, mark it as fail, mark it as success, or whatnot. The prefetch defines our workers will consume in parallel how many messages in one go. So let's say we set it as 5. So our workers will fetch 5 messages, like consume 5 messages and handle the calling of the third party APIs, retry, and that sort of stuff in parallel. Now we can even increase the number of consumers or workers as well to scale things further if the load increases, and we can see our specific message queues getting clogged. So for example, our APN queue gets overloaded and towards getting clogged. Okay, so our iOS message queue, basically we bumped up our consumers to 10, so we can even bump up our consumers. Okay, and then we set up prefetch as 5. So what will happen at a given time, each of our worker will fetch 5 messages and handle things in parallel, and then we have set 10 workers or consumers dealing with the messages coming into the published to the message queue. So we will have 50 messages in parallel being dealt with, and once they keep dealing with these messages, it keeps pulling more and more as soon as they keep on completing each one of it. Now let's say retry also fails, as it can be that third party notification provider face some outage for a couple of seconds or minutes, which is again less likely, as these are Firebase, cloud messaging, Apple push notification, and those sort of service providers which have very good availability, like 99.9% available and that sort of stuff, as it's unlikely, as it has 99.9% or higher availability guarantees. But let's say retry also fails, like we are retrying and it also failed. Okay. Now, as per the use case, it depends how critical our notifications are. Now it brings down to us to discussion of the use case. It can be, let's say these are some ads, like these are some ad notifications. It's fine even if data gets lost, that these notifications got constructed but didn't get delivered to that specific user device, SMS, email, etc., that sort of stuff, right? So these are just ads. It's fine even if couple of ads didn't get delivered or failed even after the retry mechanism plays out. Okay. But if these are critical notifications, let's say of payment reminder or order delivery, these are considered to be highly critical. We can't let them to be failed so easily. Like we tried, our workers tried hitting the third party notification provider once, then retry mechanism kicks in, and then it tried couple of times, let's say 2 or 3 more times, and it marks as fail, because these payment reminders, order deliveries, these sort of things are highly critical. What we can do, let's try to think of another solution, what can be done. So let's take iOS message queue. The workers or the consumers consume the message from it, and they are hitting the third party notification providers, APN in this case, which will, where the adapters will map all the relevant things to APN's API to make sure that APN delivers it to the user specific iOS device with all that message, payload, templates, device tokens, and all that sort of stuff. So this is where, so what we can do is, let's say it tried once, okay, and it failed with timeout, okay. It hit the timeout of, let's say, 1 to 2 minutes, whatever we have set. It goes back, it kicks in the retry mechanism, okay, kicks in the retry mechanism. Again, this hits 2 to 3 times and all get failed. All get failed. What can be done is we can persist those critical notifications. So we can have criticality defined for our notifications, and if the criticality is high, like as we just discussed above, these are payment reminders or order delivery notifications and not like some ads, so we can persist them in our notification log, sort of like that. So we can persist in our database and call it notifications log. Okay, we can push the critical notifications to a notification log DB. On that, we can have a retry notification service run at few intervals to send those notifications again. And then this notification, retry notification service can push to specific message queues again, and things can play out again. Or even to a separate, let's say a retry message queue, like to same message queues or a separate retry message queue to play things out again. Play things out again. This retry notification service runs at few intervals, so can be thought of as a cron job, which gets run at some intervals, extracts whatever is there in our notification log store, cron job on our notification log store DB, and keep cleaning notifications from there. It keeps on cleaning things. Makes sense. We have dealt this in a decent way. Now, it's also good to talk about rate limiting during the interview discussion. Like, if we send out too much notifications, our end users will eventually opt out of it. And that makes sense. If we keep on sending very high number of notifications, firstly, it would put a lot of load on our services, on our notification servers, on our database, and all that sort of stuff, on our message queues, and these hitting these third party notification services, they also charge us. So eventually the users will opt out of it and it won't be a good use for us. So having rate limiting rules defined is also a very good approach. Example, we have APN, FCM, email, SMS, etc. We can define that all will have a maximum of 5 notifications delivered per APN, like per iOS, Android, SMS, email, per user per day. They should be implemented alongside notification server so that they don't even get pushed to the message queues, right? Unnecessary clogging them once they hit the rate limits. So what we can have is we can store these rate limits in a DB. In a DB, we can store these RL rules, our cache, right? Have a cache strategy. So store it in a cache, say, let's say Redis, and then our notification service, right, will first check in the Redis if we have hit the RL rules for this user, at notification type level, before even processing things, forming that message payload, extracting out other stuff like user device token and that sort of important stuff, right? And doing the heavy computations and even pushing it to message queue. So before all of this, we can check the rate limiting rules and our rate limiting values for this specific user and the notification type level, and based on that decide to proceed further if the rate limit hasn't been hit yet, or to drop it.